So, hello everyone. Welcome today on the conference right after the keynote. Thank you for being here. Today we are going to talk about safety again after keynote. This time we're going to talk about safety introduced by user libraries, and we're going to explicitly scope on quantities and units library. My name is Mateusz Pusz. I'm the trainer consultant, and also I'm working at EPAM Systems right now. So I'm working on this library for 7 years right now. Not alone. I have some contributors in the room as well right now. For example, Rolf is one of the contributors and co-authors of the proposal. And we are going to talk about how this library improves our daily safety. And why we care about this? Because the future is here. If you remember, like not that old movies where the main actor was sitting inside of the car and was driven in an autonomous vehicle straight to the destination. This movie was typically set in distant future, like 2200 or whatever year, right? But right now, actually, this thing that was so distant a few years ago, right now it becomes reality, right? The autonomous car starts to drive on our streets, and we start to depend with our health, with our lives on those machines, right? You want to go to sleep, you want to work on your computer, while the machine is doing everything for you, taking care about you. And it's not only about autonomous cars. Those things happen to be everywhere, right? We live in the world where more and more people, ordinary people, depend on the computers, machines with their lives daily. Autonomous cars, surgical robots, healthcare devices, plenty others. And there will be more and more with every year to come. C+ safety is a major concern right now in our industry. That's why we are having so many talks at this conference talking about safety, including the keynote that just finished, right? We discuss potential improvements in the language. We talk about value semantics. We talk about improving fundamental types that may be safer. We talk about updating core language rules to, for example, improve initialization or how we pass arguments to a function, as we just learned, right? And also, we are talking about providing safer, higher-level abstractions in the library, so we can have better tools that provides more safety to the users. And the users, I mean the developers, needs help. Even though we have trainings, we have talks, we have guidelines, it's hard to find experience in life-critical software. And more engineers start to write the software in recent years. Some time ago, like 10 years ago, 20 years ago, it was just a few of us that was actually concerned about safety, life-critical software. Right now, more and more people have to do it, and this experience is hard to come by. The training alone will not solve this issue because it's still a really complicated subject. I'm going to talk about some accident that happened, not in programming, but basically in our lives, in our history, about units, because units by themselves are hard, even aside of programming, even aside of C++, right? We tend to have issues with understanding them and communicating them properly. So even if you are the best C++ developer, you may still make mistakes because of it. And that's why we're looking for better abstractions and try to improve how we communicate things. Also, it's important to say that code written for different projects is not often written by C++ experts. It's written by technicians, by physicists. They just have to do their work, and they just actually use C++ as a tool, right? So they are not experts. They will not understand template programming messages. They will not be able to resolve some really strange ADL issues in their code. They're just using this as an ordinary tool to do the work and calculate all of the physical equations with the solution. And the market for this is really broad. Typically, when we think about it, we think about like aerospace, autonomous cars, embedded industries, but this is much, much broader. We may use this library in manufacturing, maritime, freight, military, astronomy, 3D design, robotic, audio, which is a perfect example by Roth on cppcon last year, medical devices, GUI frameworks, finance, including HFT, also uses abstractions provided by this library. And this is not only important for developers, but also for end users. And well, sometimes it is the same. We as developers are also end users, right? Being driven by the autonomous car home. So we would like to be able to depend with our lives on those devices. Sometimes it's scary when you know how it's written under the hood, right? To go to the car and say, just take me there, right? I've saw, as a consultant, plenty of software. I know how it's sometimes written. I'm going to show you some examples later on. And I don't want to pick any specific industry right now or specific product, but sometimes it's scary to actually depend on such a software if you know how it's written in general in the industry, right? That's why we want to improve. But let's first talk about why units are hard in general. And let's talk about several mistakes that actually happened during our history. Let's start with the first one that I actually found as a one that was written. So Christopher Columbus on October 12, 1492, unintentionally discovered the route to America from Europe. He planned to go somewhere else. And I'm going to tell you in detail what happened later on. But during his travel preparations, he made a few mistakes. One of the biggest mistakes was that he actually used a different measurement for length that he actually planned during preparing for this travel. We're going to talk about this case in detail later on, so I'm not going to spend too much time on this one. Another one is a famous vasa warship. In 1628, it accidentally sank during her maiden voyage. It resulted in the death of 30 sailors on board. One of the reasons for this was that the hulls of the ship were asymmetrical, because it turns out two groups of workers were working on the left side and the right side, and they used different units of length for that. The archaeologists, when working on the construction side of it, found two rulers that were calibrated in Swedish feet on one side, and rulers on the right-hand side that was actually using Amsterdam feet, which was 1 inch shorter than the other one. That's why actually it has asymmetrical sides, so it was tending to collapse on the side, and also taking into account that actually the center of gravity was above the water because, well, they did some issues. They just made the decks too heavy for this boat to put all of the cannons on them, just for sure that they will not collapse. It was just tending to collapse on the side when just some wind comes on the water. Air Canada flight 143 ran out of fuel on July 23, 1983. Fortunately, no one was injured here, no one died. It landed like this one on the airfield. But the problem was that the fuel was calculated in pounds instead of kilograms by the ground crew. And actually, it ran out of fuel at the 12,000 meters. British rock band Black Sabbath, during its Born Again tour in 1983, they ordered a replica of Stonehenge as props for the scene. Unfortunately, the manager of the band written the dimensions in meters when he meant feet. So as a result, the props were so big that most of them had to be stored in the storage because they didn't fit any scene around the world. Just a few of them actually fit on this huge arena, and most of them will have to be stored somewhere else. And they say that it costs a fortune to make, but there was no building on Earth that could fit it. Actually, the props here are bigger than the Stonehenge itself. On April 15, 1999, Korea Air Cargo Flight 3616 crashed due to miscommunication between pilots and the first officer. First officer actually confused 1,500 meters to 1,500 feet and ordered the pilots to descend. Pilot did it, and actually 3 people on board and 5 people on ground were killed because of it. Probably you know this case, Mars Climate Orbiter. In 1999, it failed to enter the Mars orbit. It disintegrated probably in the Mars atmosphere because it was too low over the planet when it was entering the atmosphere. And the source of this is claimed to be the miscommunication issue between NASA and Lockheed Martin engineers. The NASA was using SI units as in specs, but Lockheed Martin was using US customary system, and that's why they didn't communicate properly in the interface between two libraries provided by two vendors. Clarence. Clarence is a tortoise that in February 2001 was moved from one zoo to another. And the new location asked via phone, how big is the tortoise? And they've heard it's 250. They thought it's pounds, but it was kilograms. They built an enclosure for Clarence, and they found out that during the first night in the zoo, the Clarence just destroyed the enclosure, and they found it in the garden next time in the morning, eating all of the vegetables. In December 2003, one of the roller coaster cars in Tokyo Disneyland, a Space Mountain attraction, suddenly derailed. The axle was broken, and this was caused by the migration of their measurements and specs from imperial to metric units. Hohenbrücke Bridge that joins the Laufenberg in Germany with Laufenberg in Swiss was built concurrently from two different sides of the river by two teams. It turns out they didn't meet in between. And the reason for it is that it turns out that there's more than one sea level. Switzerland is using different sea level. Actually, this is the Mediterranean sea level, and Germany is using a sea level that is according to the Amsterdam sea level, which is North Sea. The difference between those is 27 centimeters, but if you are thinking that the difference was 27 centimeters between different parts of the bridge, you are wrong. You are going to learn about this a bit later, what was the actual reason. An American company sold a shipment of wild rice to Japanese customers, quoting price of 39 cents per pound, while the customer thought that is per kilogram, and then they had some issues to solve. Who should pay the money? Not more than a year ago, The Guardian provided an article saying that Malawian swelters with temperatures nearly 68 Fahrenheit above average. If you know something about Fahrenheit, that's a lot of Fahrenheit, right? It turned out that this article was appearing in the European version first, and then they translated this to US market. And the actual difference was of course, not that big. It was 32 Fahrenheit, not 68. And this comes from the fact that temperatures are hard and how you talk about them. And there's plenty of documented issues with medication dose errors. It's like happens all of the time in many different places that someone provided an incorrect dose according to these specifications. So none of that, maybe besides the Mars climate orbiter, was connected to programming issues. It just units are hard to communicate, and that's why we need to take care about them, especially in our software, so we don't do mistakes like that. And what we do actually in production, this is a project I contributed to some time ago. Actually, that's why I started to work on this library, because I found how bad it may be. This is an open source project, but also through the years of my consulting career, I found that you can find the same code in production, done really similar way, right? Double everywhere. Now consider what happens if you refactor this interface, like replace the arguments or add a new one in the middle. That's insanely hard to make it work. Also, plenty of magic numbers. I would not dare to touch this function right now. I don't know what those numbers mean. Some maybe I can reason about, right? Like this one is probably the known component of the centigrade, right? And Kelvin temperatures. But the rest, I don't know what's the origin for them right now. but it works. And no one dares to touch it. Conversion macros. This is what we do on a daily basis to convert between different units, right? We have deck to rad, rad to deck, to MPH, to kph, and so on. 2 miles to feet to meter. Plenty of those macros in the entire software. And if you think that this is consistent, it's not. This is the same repository, different headers, different definitions for the same thing. So depending what you include inside of the same repository, you get different answers. It's hard to keep things consistent. And talking about consistency, this is the same header file. And those functions are written like here, one by one after another. Do you see any issues? Let's see. Lat, lon, lat, lon, lat, lon, lat, lat, lon, lon, lat, lon, lat, lon, lat, lon, lat. Easy. But this is not only. If you see carefully, there's one more mistake, one more issue similar to this one. Which one? Distance, bearing distance. It's consistently inconsistent in the same header file. And this happens so often. So I've written this library, MP units, and it's also right now considered for standardization, hopefully C++29. So there's still a lot of work ahead of us. But actually, we don't have that much time left. So we have to hurry in order to catch the C++29 train. This library is using C++20 and optionally 23 abstractions if you have support for 23, but it should work with 20 only. Provides compile time safety, which means that you have correct handling of physical quantities, units, and numerical values. Of course, it has to provide all of the performance, right? It has to be as fast or even faster than working with fundamental types. Not slower than double, sometimes faster. No runtime overhead, no space size overhead, because there's also maybe obvious in C++ that you're not playing with size overhead, but if you analyze solutions from Java or Python, it tends to be like 40 to 100 times bigger than the actual double being used under the hood. Because all of those polymorphism, all of those virtual functions, it's actually hard to count the size in those languages, but I tried, and this is a lot. And those overhead is a lot in those languages. Great user experience. As I said, it has to be user-friendly for everyone, not only C++ experts, but also for people that do not know C++ that well. You have to be able to understand what is the problem in your program by reading the compiler error messages. That's why you put a lot of emphasis to make those compile time errors readable and also to provide great debugging experience, because you also want to see the type clearly in a debugger to know what you are dealing with. And scope. We have to be able to express any unit's magnitude, huge, small, and also floating point, like between degree and radian. We provide support for system of quantities, system of units, affine space abstractions. We have highly adjustable text output formatting. We should be able to work with scalar, vector, and tensor quantities, and natural units systems. And it should be easy to extend. The conformance templates of the compilers looks as follows. As I said, we need minimum support is C++20. And this is what's required to compile this library. But we have some extensions for 23, for example, using explicit this parameter and some other things as well, if you have those. We also have C++ modules. If supported by the compiler, I still didn't made it to work on GCC 14. There are some bugs there. At least I couldn't make it work. But in general, in GCC and Clang, you can work with quite an old compiler right now to make it work. Unfortunately, for Microsoft Visual Studio, still none of the compilers, even the latest one, do not support my library because they do not compile properly C++20 code. Hopefully, MSVC folks will fix the issues and it will actually start to compile this library. And also, I've heard that 2300, so the synthesis proposal, also is the only one that doesn't compile it is MSVC. So there is some work to be done by Microsoft team. You can find the library in GitHub, Conan, and Compiler Explorer to play with it right now. If you want to read more or follow this standardization, I provided this paper a few years ago where actually we were asking the committee if they are interested in the subject, and we provided some overview of the possibilities on the market. And those are the new papers that were provided lately with the specific proposals of the design of the library. And there's also a lot of associated proposals where we want to introduce number concepts, where we are actually standardizing basic fixed string, which may be useful in other domains as well, and some other extensions that will allow us to provide better abstractions in the library or implement this in a faster way. It seems there's a high interest in standardizing this thing, this library. Committee doesn't say no, they are interested in standardizing this. So hopefully it will end up in the standard, so everyone will be able to use it. But anyway, it's right now, as I said, provided on GitHub. You can just start playing with it, and please provide feedback as soon as possible, so we actually have even more production experience before standardizing this in the standard. Quick domain introduction. Before I actually show you some code, let's talk about the domain for a moment to better understand what are the terms and definitions that I'm going to refer to later on. First of all, we are having not only system of units that most of us are aware of, but there are also system of quantities. And it is said explicitly, for example, in the SI, the International System of Units, that it depends on so-called ISQ, International Standard of Quantities, actually standardized by ISO 80000. So this is the same organization that standardizes C++ language. So we have system of quantities. System of quantities is a system that puts all of the units, representation time numbers aside, and just talks how quantities relate to each other. So there are definitions like speed is length by time, right? Just this, no units, just saying how those compose to provide hundreds of different quantities. And there are system of units. System of units says, okay, so we have this speed, and then length will be in meters, time will be in seconds for this specific unit system. For another one, we may say this is in miles or whatever, or in meters or centimeters for CGS, for example, right? So this is how it works. So set of quantities is a set of quantities together with a set of equations relating those. And you have this ISQ, as I mentioned, standardized by ISO 8000. It's a system of quantities based on the 7 base quantities. System of units provides base units and derived units together with multiple submultiples, so basically prefixes, for a given system of quantities. And the most important example here is International System of Units, SI, provided by CGPM, and is based on the ISQ by definition. Here are the abstractions we are talking about. Dimension. We have 7 base dimensions or quantities with base dimensions with dimensions in ISQ. Length, mass, time, electric current, thermodynamic temperature, amounts of substance, and luminous intensity. Everything is built on top of that. However, dimension is not enough to provide correct abstractions. And that's why we have also quantity type. Besides the base dimensions and base quantities, we have also derived quantities, where, for example, force or speed is denoted by some product of base dimensions. So we don't have a dimension of force is not a dimension, but quantity of force has some dimension that's basically a product of other dimensions from this list of 7. Quantity type. As I said, dimension is not enough to describe a quantity. We have quantities of different dimension, like length, time, speed, power, which is fine with dimensions-only approach. But we also have the same dimension, but a different kind, like work versus torque, frequency versus activity. For example, the plane angle and solid angle, right? Area versus fuel consumption. If you think about it, it is the same dimension, right? Fuel consumption are liters, so volume, by distance, 100 kilometers, for example, right? So volume per length is just an area. Would you like to mix area and volume consumption in the same equation in your program? From the dimensional analysis, it would be totally possible, and most of the libraries on the market will allow you to do that. But probably in most of your products, it's something that you should not do properly, right? That's why we need those additional abstractions like quantity types. Also, you have the same dimension and kind, but still distinct, like radius, width, height. This is very important. For example, I had the feedback from those guys that work on, what's the name of this? On those robots that basically do fun stuff and put all of those bugs, all of those boxes in the compartments in the magazines. Boston Dynamics, right? Oh, Boston Dynamics folks, right? They have plenty of those issues right now when they're building this robot that is able to help with packages. And they say that they mix like width, height, and length all the time when those boxes are being processed by the system. So this helps a lot, Boston Dynamics, right? Potential energy, kinetic energy, thermodynamic energy. Those also should not be mixed. If you have an equation taking the kinetic energy, you would not like accidentally put potential energy into this as an input, right? Those are different things, and you should not mix them. Of course, you can be able to add them to get the mechanical energy or total energy, but you should not be able to mix them if you care about it. Next, the standards define something called quantity reference. Quantity reference may be a measurement unit, and this is the most common use case, and this is the use case we are going to scope on. And this is basically designated by conventionally assigned name and symbol, right? And we have basis units for all ISQ dimensions, and we have also derived units for derived things like heat capacity and entropy uses Joule per Kelvin, but also the standard says that if you have 1 per second, but you are dealing with frequency, you should call it hertz. If you are dealing with the same, but for activities of the radionucleosides, you should call it becquerel. So sometimes you may share the same unit between different things. Sometimes you have specific names for those separate abstractions, even though if they are dimensionally the same. And besides if you are interested, quantity reference is not only unit, but also measurement procedure or reference material. Those, of course, are not things that we are going to care about in C++ program. Quantity, in the end, is a number and this reference, so a unit. And you may have different quantity types. You may have scalars, like length of 123 meters. You may have vectors, like force of these newtons, or tensors with a stress quantity. Basic operations. For sure, you may be able to divide, multiply those. This is easy. This is what we are doing with Chrono. You can convert between different units or add them with a common unit. This is the same what we know from Chrono duration. And you may have derived quantities when you actually divide or multiply different quantities or the same quantities to get another quantity, or divide them to get the dimensionless one. Or you may have an inversion of a quantity, like time, to get a frequency. All of this should be supported by such libraries. So let's look how such library can solve our problems. And this is the problem statement. This is how you write code when we don't have the library in our hand. We use doubles everywhere, or other fundamental type, or maybe our strong type in the program. But as it doesn't track any unit, you have to track the unit in the identifier, saying this is distance in meter, speed in mph, and so on. So all of those take care about following the unit. Otherwise, you don't know what you're dealing with. And this is a good practice because in many cases in the program, for that I reviewed, we don't care about those anymore at all. I've seen code like this, but without the postfixes, and it's even harder to reason about. You just have length of 30, and you don't know what you're dealing with, right? So putting a postfix with a unit is a good practice here that actually allows us to have track somehow what happens here. Convention factors, magic numbers, bad thing. That's why we're putting this to some conversion macros. Also bad thing, right? We may do better. We have consexp. Let's do consexp. Is it better? Not really, right? But we have concepts here, and with this consexp, we can also provide all of the conversion factors. When you're having strong typed library like this one, you don't have to track units anymore in the identifiers. Those are tracked by the types. So you just write the identifier. The type is actually here. It's just, you don't see it because I'm using class type argument deduction, so-called ctat here, which removes the information from the user. You don't have to type it, which is often better because it will always be the most efficient stuff you deal with. And you provide the units here as in the code to specify what is the unit of those. When I divide stuff, I don't have to introduce any intermediate things. I can just divide stuff and say I want to have the result in seconds. And I will have the result in seconds, and then I can print it, and I will get exactly the same answer. Right? So there's no need to track units in the identifiers. The library knows all the conversion factors. There's no magic numbers. And there's no need for intermediate results like this one to make the conversion macros we use, or context parameters, context conversion factors, in order to make them happy. The main goal of such libraries is to generate errors, and those errors should be easy to read, easy to understand. When I make a mistake here, I said that the speed, or time in this case, time is multiplication of length and speed, and the same here. This is, of course, the error in calculations, and you should be able to catch this error easily. Of course, in the left-hand side, you will just get an answer. No errors reported. Right? Here, you get the error like this one. I know that maybe you cannot see it right now too well, but it's not that long. But there are some fun factors here that I want to show you before I will optimize the error message for you a bit. This is the output from the Clang. Clang actually does really well in terms of the compile time error messages, but also provides those strange curly braces. Actually, I have a challenge. The most braces I can create in the compiler message. And I submitted some bugs on those to actually improve that. Hopefully, it will disappear soon. And this is how it looks when you disappear stuff. You have information here, no magic number, no matching function for call to in. Constraints are not satisfied because unit is not compatible with, evaluate to false. And we say here that second is not compatible with quantity of power length 2 per time. Right? So this is length to the second power per time. It's not speed, it's not time, as written here. So you can quite easily find out what's wrong here. Of course, there is like C++ specific concepts, verbosity, but at least the types are quite readable. Hopefully, we'll be able to improve that a bit with C+26 changes that allow us to print our own text at compile time. And then we can maybe provide something like first line stating exactly what's wrong and then why with concepts statements. All right, let's talk about the interfaces. When you provide interfaces without the library, you have to again track the units, not only in the identifiers of the arguments, but also as a postfix to a function name. You say this time to go returns seconds. So you have the input in meters and speed in kilometers per hour and return seconds, right? Those are specific units we are dealing here with those conversion factor. With the library, you just say quantity in seconds, quantity in meters, quantity in kilometers per hour, and you are good. With C+20, we can write those things. It was impossible before C+20. We are not able to write an expression like this one in a template parameter. Right now, we can write so nice things with C+20. And now if you try to assign stuff to this, this is how it looks for the left-hand side. This is how it looks in the right-hand side. Right? I have distance in kilometers. I might say this is distance in meters. Actually, I don't need those two lines, but I will use them in the next slides. Only one line will suffice here for this specific case. I have speed in kilometers per hour, and I pass it. And get exactly the same result as expected. When I pass a different unit than expected, this says I want to have distance in meters, this quantity in meters. and they pass kilometers here. That's why I said I have 2 lines here. Of course, this code will compile, provide the result, which is incorrect, because this is the same distance, expressed just in a different unit. This one will make the conversion for you. And if there's no truncation, it will happen implicitly. If there's a truncation, you will get a compile time error saying, well, you may lose some quality here, so I'm going to stop to compile and force you to think about this a bit more. If I accidentally replace the arguments order here, because maybe either I was providing arguments here in the correct order, or I refactored the function and forgot to change the call site. This happens so often. Again, this provides some result. Here we get another error message saying could not convert speed from quantity of derived units kilometer per non-SI hours to quantity of meter. This error is clearly readable, and this is just one line in GCC that prints this one. When I'm providing arguments correctly, but have again the error in the calculations, I get another result and another error saying that we cannot convert this thing to quantity of seconds because it's something different. So it provides all of the safety as expected. And also, it is the same fast for both of those at runtime. Those are the instructions done on the left-hand side. Those are the instructions done on the right-hand side. Those are the same instructions. They are just reordered because I'm doing the multiplication in a different order as well here. But besides, it's exactly the same assembly. But this is not our target for generic libraries, at least, because here you are forced always to convert to meters, kilometers per hour, seconds, which may be suboptimal. What you want to write often is writing generic programming code like this one. This is impossible to write without the library. You cannot write it with doubles, because then you don't know what you are dealing with at all. Right? I think I take quantity of length, quantity of speed, and I result quantity of time. And this uses the concepts from C+20 and allows us to have better abstractions. So I can write, for example, distance to turn, 400 feet, car speed, 40 miles per hour, and time to go, and then represent it in seconds. And I have the information that I should turn right after 6.8 seconds to actually turn my car, autonomous car, into the turn. I'm using feet, miles per hour here. I can use kilometers and kilometers per hour on a much longer scale, bigger scale, because this is distance to Garda Lake from my home, average speed I expect to have on highways, and I will get the information that time travel to Garda is nearly 16 hours for me. Or I may prepare to have marathon distance race. I provide the distance, I provide my pace as 4 minutes, 40 seconds per kilometer, for example, as expected pace. I pass it here, and what happens? Does it work? It doesn't work because pace is not a speed. Sometimes when I'm talking about my Garmin watch to my wife or other guys saying this is my pace, but what it means? Pace is not speed, right? So we get a compile time error saying that, well, quantity of seconds per kilometer cannot be passed as speed. You have to do 1 per pace to get the result. And you are fun, right? And it happens so often in many places. I've seen so many errors putting weight as a mass. And actually it's not the same, right? Because weight is a force. People tend to confuse similar terms that actually mean something different. Or I may use quantity points. So affine pace abstraction saying this is cloud base, this is my glider altitude, and this is the strength of the thermal I'm inside going up in the up until the cloud. And I can find out that I should exit thermal in 144 seconds, or otherwise I will be sucked in by the cloud and will not see anything. Right? So I have 2 quantity points. When I subtract them, I have a quantity and a thermal strength here. It adds additional safety to bring affine space abstractions here. So if you're not aware of this term, it's something similar to duration and time point in Chrono. So this is how the usage of the library works, what we deal with that, and let's talk about some safety features in isolation. So we have safe unique conversions, as you've seen before, right? We have, for example, 5 kilometers. I may say quantity in meters, and this will just work. Or I can assign this quantity of 5 kilometers to quantity of meters, and it's also fine because you always can express kilometers in meters, assuming that the underlying type will not overflow, but we cannot actually care about this in the library. If you want to care about overflows, you should use some stronger abstraction as an underlying type that will prevent overflows, like safe integer or whatever. But the library assumes that it is fine, because if you have a distance in kilometers, you always can express it in meters with no truncation of data. Magnitudes of source and destination are known at compile time. That's why we can do this conversion. And the library provides this conversion factor automatically for the user. For those ratios, we cannot use std ratio. Std ratio has plenty of limitations and issues. In std ratio, we are always using std int max t. And basically, this is a big lie. Int max t will not be int max for long. Initially it was planned that it will extend with more versions of the standard. When you put something longer and longer, it will always grow. But it was stated that it's an ABI breaking thing, so it will never grow. Int max t will always point to what it points right now, because otherwise you are breaking ABI. It cannot be re-aliased to anything else. So if you get like SIMD types, whatever bigger in the standard, it will always be those 64 or 32 bits depending on the platform it was provided. And this means that std ratio will never grow. And right now, it cannot express, I think, 8 out of SI prefixes at all. Or things like this one, like electron volt, Dalton. Those are not possible to be expressed with std int max in std ratio. And also, there are things like conversion between radian and degree that involves pi, which is irrational. So in this case, you cannot express it with ratio. So you have to figure out better ways to do so. And that's why we're using magnitudes. Magnitudes are now on abstraction, and we are saying, for example, that kilo is Mach power 10 to the 10 to the power of 3, let's say, right? This is kilo. And then I can say I have meter, second, one line for each definition of a unit. I can provide symbol and the kind of it, and the Mach power. All of this are values that are new in C++20. In C++20, I can put non-class template parameters here, and this just works. One line per one definition is so useful. And then I can write unit symbols in a separate namespace, km, kilo, meter. Unit symbols are provided in an isolated namespace because they bring a lot of short identifiers to the scope, and they may collide with your own parameter identifiers, variables, and so on. That's why you have to bring them as opt-in rather than being there by default. If you want them, either using declaration or using directive, and just use them. Or you can also define things like by yourself, just using this short syntax to have some short names for something longer. Of course, not everything is just a prefix in SI, because, for example, there is no prefix for 60 to have minute or hour. So here we're saying max 60 times second, and this will be proper result for minute. Again, using non-class template parameters. Or you have some ratio now. Ratios for example, yard based on meter. You can express it this way, and this will also work. So this is how conversion factors work. Preventing truncation of data. It wouldn't be fun if our data will truncate it on the highway and the sign will provide 0 as a speed limit, right? But it's so easy to do actually when you are dealing with integer types. So let's see, if I have 5 meters and I will try to express it in kilometers, I will get 0. Right? This is potentially scary and unintended. So that's why we get compile time error in the library. Either when you convert this within, or you try to assign meters to kilometers. On the other hand, floating point type representation is considered to be value preserving. This follows what std cron duration does right now. I know that this is a lie a bit, but we don't have better ways in standard to actually express that for now. there are proposals that we are cheering on that will provide type trait, saying if the conversion from one type to another is value preserving or not. If this type trait will be provided in the standard, then we are going to depend this library on this type trait. But for now, we cannot do better. We are following what Chrono does, saying floating point, not truncating, integers truncating, and that's the best we can do for now. Hopefully, we'll be able to improve if this type trait is standardized. But here, I'm using double as an input. So right now in works, conversion works, or I can say explicitly in double kilometers, or this type, if I spell it explicitly, also uses double as an default representation type here after the comma. So it also works. If I want to stay in the integer domain, I have to be explicit. I have to say force in kilometers or value cast to kilometers Q1. And with this, I am forcing the truncation to happen explicitly in the code. So it's easy to spot during code reviews and make sure that this is actually what we want to hear. By the way, if you have a good idea how to rename this function, it will be good, because when you're dealing with quantities library, it's hard to read force in kilometers, right? When you think about it a bit more. We're looking for a better name here. All right, and also, when you have floating point value and you want to assign it to int, again, compile time error, truncation may happen. So you have to use things like value cast again and make it work. But let's move to the Columbus case. Why Columbus thought that he reached India? Columbus started from Europe. Actually, he started from Canaries and went west. During his preparation to the travel, he met Abu al-Abbas Ahmad ibn Muhammad ibn Farid al-Farghani, aka Al-Farganus, who was a medieval Persian geographer. Columbus learned from him that the degree of latitude spans 67 miles. And he said, well, on the equator, the latitude should be roughly equivalent to the longitude. Right? So this is what he expected to actually travel as a distance for 1 degree of latitude. So let's try to code it. Estimated degree of any unit of length here, called mile. And we have named unit degree, mag ratio 56, 100 times the mile we provide here. But what is a mile? And this time, in Europe, we used Roman miles. Roman miles was based on the Roman foot. Roman foot actually was the length of this guy on this statue. 296 millimeters. This was the origin for the Roman foot at this time. Roman pace was the length of every other step of a Roman legionary, and it was considered to be equivalent to 5 Roman feet. And then Roman mile was total distance of the left foot of a Roman legionaries hitting the ground 1,000 times. It was a simple system of units used in this time in Europe. So we have Roman foot being 296 millimeters, and we have Roman pace being 5 times of that, and Roman mile being 1,000 of the pace. All right, so far so good. It turned out that the Al-Farganus was not from Europe. He was Persian. He was Persian, and in Persian they use Arabic mile. And this is what he meant when he communicated the distance to Columbus. Persian mile was actually, it's claimed to be a bit more than 2,000 meters. So a long mile. And this is what actually he meant when he was talking that this is 56,67 mile per degree. And also this is actual mile that we know right now is 1 minute of arc along the Earth's equator. This is the correct ratio that we already know as current science says. And we have Columbus degree to be estimated degree of Roman mile, Al-Farganus degree being estimated degree of Arabic mile, and equator degree being the actual length of the equator degree that we measure today. That's how when you write an error function taking two quantities, you may ensure that they can be subtracted from each other, And I have approximate measurement, exact value. I do ABS, all the regular math with quantities and constraint like this one. And I can write Roman mile is 1 Roman mile in meters, Arabic mile in meters, and we check the error. It turns out that Roman mile was 1400 meters, nearly 1500. Arabic mile was really long, and there is 31% already involved in the Columbus calculations because of miscommunication of units between him and Alfraganus. Let's try to find out the equator length that was estimated at this time. Columbus estimated the length of this in his degrees, Alfraganus in his, and this is the actual one. When you try to print it in nautical miles, this time we're going to see that Columbus estimated this one, and this actual one. So actually, Columbus was quite yeah. All right, I lost my thread here. But yeah, the error introduced by Columbus basically was not that big as we expected, because Alfraganus actually overestimated the length of the equator, right? So the error actually is a bit smaller than the previous one, not 30 but 24%, and that's why it was a bit lucky to Columbus. Also, Columbus thought that he reached India based on statement from two Estradas, which is the apocalyptic book in some English version of the Bible that says 6 parts of the earth are habitable and the 7th is covered with water. So at this time, people believed, because Bible says that there's only that basically there's only 1/7 of the earth covered with water, while the rest has to be ground. So he said, so taking this into account, there should be only 68 degrees from one land to another land on the other side. 68 is not much if you know globe, right? But this is what he assumed based on this statement from Bible, and used his own degree for the calculations. Actual distance for Tenerife to Bahamas is 6,000 meters. Tenerife to Japan is 10,000 nautical miles. Notice how I always change the units here, as all of the values are correct, but I don't care which units are being used here, just as a side note. And I have here all of those printed in nautical miles. It turns out that Columbus' distance that he claimed to travel was 3,000 nautical miles. The actual distance to Japan, even not to India, would be more than 3 times longer. If there was no America on the travel on the path, all of them will die with no water, no food, and we'll never hear about Columbus anymore. Distance error, 70% error of his estimations. Fortunately, there is Bahamas. Bahamas is really close to what Columbus expected to be. It's just 200 nautical miles longer. So that's why he was so sure he actually reached the destination, because it actually was similar to his calculations. But now I know why he was so happy when he read that. It was so close for them to actually fail on the mission. I show you this story because I think it's quite an interesting one, but also I show you plenty of units intermixed with each other. As you noted, I use nautical miles, Roman foots, Arabic miles, I use meters, kilometers, and all other, and you didn't have to ensure that my slides are correct. It just worked, right? And this is what we want to actually achieve, providing such a library, right? Imagine you have to implement Columbus story with just double and conversion macros and make sure it is correct. It would be much harder to prove. Also, plenty of people say we have homegrown solution for us. We don't need a standard one. It's not that easy to do. I already proved plenty of people that their solution is wrong or lacking because they didn't consider corner cases. It's not that easy as it seems. I'm doing this 7 years already, and still plenty of work ahead of me. And my library is probably the most, I'd say, advanced and complete from all the libraries on the market. There are plenty of possible safety issues and corner cases as well, and let's try to see some of those. We consider Chrono to be a really good example of safety and interface design. It was a groundbreaking change. I love Chrono, but with years, we learned that there are some issues still as well. If I type things like this, I have vector of chrono milliseconds, and I put xvec mplacebex 42. This works fine. This is the explicit constructor. Explicit constructor can be called from mplaceback, and this puts 42 to milliseconds. If I refactor this to microseconds tomorrow, this still compiles fine, but it's incorrect. Right? With physical units library, you should always try to be unit safe. If you try to write something like this with a proper library, you should get a compile time error. You should always provide unit assigned to a value. If you refactor the interface, it will be fine. Either it will convert or have a compile time error saying there is truncation. Right? So if you always provide unit at construction, even if it's the same one, then you are lucky. There's no conversion, but it's always safe. The same goes if you're dealing with some third-party libraries, legacy code that actually needs to have, for example, integers as seconds here as an input. This is a legacy function. We cannot change it, provided by third-party library, and you have to get the value from it. If you have stood chrono duration in microseconds here, and you place back 42 seconds to a function expecting seconds, then plenty of people will write just .count here, because it looks correct. Seconds, count should be fine. But the intermediate type is microseconds. And this is what you get from count, right? So it's not 40 seconds anymore when you print it. Of course, there's duration cast. And you should always remember to put duration cast before you do count. But you will be surprised how many people don't forget about it. Don't remember about it, forget about it, especially when they see that the unit matches. It may match even today, even if there are seconds here, it may match today, but not tomorrow. Again, the same issue. So in unit-safe libraries, you should always provide also a unit when you get the value, numerical value in seconds. And then you are always safe and correct. Do you remember Clarence? Clarence didn't have big enough enclosure in zoo, right? If you want to big an enclosure for Clarence, this is what you do without units library. You say this is a box. We have length in meter, width in meter, height in meter, and you get the arguments, length, width, height, and just create this class and have also a floor to return you area of length and width. And this is how you initialize it. And then you introduce a typical units library from the market. And you write length, 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 meter, meter, meter. Is it safe? How is it safer than the left one? Maybe unit is spelled explicitly, but still, we have plenty of issues here. Right? Just remind this Boston Dynamic case I mentioned. That's a real-life example of issues that we have. Nearly none of the libraries on the market can actually type safely help you here. And then you end up with some issues when you ask the mailman, the giraffe, to lay down for entire travel. The measure is not enough to specify all properties of the quantity. More than one quantity may have the same dimension. You have quantities of different kinds, as we said, frequency, modulation rate, activity, quantities of the same kind, length, width, altitude, distance, radius, wavelength, position, vector, and more. Quantities may have different characters, scalars, vectors, tensors. Some of them are defined as non-negative. There is more about quantities than just a dimension. That's why we introduce something that is called quantity specification. It stores not only dimension, but also all of those properties that describe specific quantity. And IC 8000 says that quantities form a tree like this one. Those are all of the quantities of length. All of them can be measured in meters. But those are different and create a hierarchy. Like every width is a length. Every height is a length, but not every length will be height. Yes? And so on for the radius, distance, and so on. Some of them even marked as vectors here. User can easily add new quantities to this tree that is predefined by the library. I can write horizontal length, being a specialized version of length. And then I can build horizontal area, being a special version of area that takes horizontal length and width as an equation, as a recipe to construct it. So this property of horizontal length propagates to all of the derived quantities immediately when you use it in the equation here. This means that horizontal area is an area, but not every area is a horizontal area. That length by length is an area, and horizontal area as well. And horizontal length times width is an area, and horizontal length by width is a horizontal area, right? So you cannot create horizontal area from length by length, but you can create implicitly horizontal area from horizontal length because this is what was provided in the recipe. So this provides you all of the type safety that you need, propagates correctly, and it doesn't require you any special casting here. Casting is needed only when you're trying to do something unsafe. But in this case, it's considered safe and it propagates nicely. So this is how you benefit from this in the code. You write, this is quantity of horizontal length with height. Horizontal length with height and horizontal area returned from here. You're explicit about the dimensions when you care. When you don't care about it, you can just ignore the fact. But in this case, we care and we are explicit about it as well. Right? This syntax creates a reference of horizontal length in meters. Right? And then we can pass. We can pass either this way, being explicit about the things, but also we may ignore the fact that those require specific things because we said all of those are measured in meters. So if I just pass meters, then I can be unsafe because I don't care in this specific case, for example. Right? If there's some third-party library that provides some safety in the area I don't care about, I can just provide unit and I'm fine because meters are used to measure everything. It's my choice. If I care, I provide specific quantities and then errors will be detected at compile time. So it's not overcost training to new users. Users have the choice to find out if they care or not in specific domain for specific quantities and benefit from that. If you replace stuff, like here, we provide height for horizontal length, you get a nice error message saying that no conversion for argument 1 from quantity of height to quantity of horizontal length, and you detect those things at compile time, and Mailman will be happy after the travel. What should be the result of the following equation? If you will want to add 1 Hertz, 1 becquerel, 1 baud, which is the unit of modulation rate, all of those are the quantities of the same dimension, but totally different abstractions. When I ask different libraries, like boost unit doesn't have baud, so that's why I just have only 2 of them. I have 2 Hertz. I thought maybe it always returns left-hand side, so I tried other way around, and I got the result 2 Hertz as well. When I add need whole house units, which is a really cool, great library on the market, really popular one, it provides a bit better answer. It just took 1 per second. So a common unit of those. It's a better answer. Pint actually has a baud. 3 Hertz. If I do it other way around, 3 becquerel. So it always takes the first argument in this case. If I ask Java, don't laugh, they don't have operators. But they provide really nice error message saying, unresolved compilation problem. The method add quantity frequency in the type comparable quantity frequency is not applicable for the arguments comparable quantity radioactivity. But actually, it is the only correct answer from all of those libraries. You should not be able to come to add those because those are separate concerns, separate quantities. IS 80000 defines something called quantity kinds. It says that quantity may be grouped together into categories of quantities that are mutually comparable. Mutually comparable quantities are called quantities of the same kind. And it says that two or more quantities can be added or subtracted, cannot be added or subtracted unless they belong to the same category of mutually comparable quantities. Quantities of the same kind have the same quantity dimension. However, quantities of the same dimension are not necessarily of the same kind. So I would say that kind of a quantity is like a dimension on steroids. It provides the same information, but and more than just a dimension. And there are plenty of quantities of dimension time -1. Angular velocity, frequency, rotational frequency, angular frequency, damping coefficient, modulation rate, plenty of others. You don't want to mix those. But right now, nearly all of the libraries on the market will allow you to mix those because they are not able to determine between them. Last thing that we had to introduce was a kind of modifier. It denotes a family of quantities belonging to the same kind. So basically it says, if I write kind of length, I basically say this is the entire tree that I shown you of all of the quantities of length. So if I do get kind of ISQ width, it will be exactly the same kind as ISQ height, and explicitly it will be exactly kind of ISQ length. And such quantity is convertible implicitly to any other quantity, like a kind of length is convertible to width, right? Because it behaves like any quantity from the tree. Quantities of different kinds can be compared, added, or subtracted. So if I define a unit, I say that second is a unit with a symbol s used to measure kind of time. Meter, the same for kind of length, and so on. Right? Now we know this definition, we can analyze it in detail, how this definition looks like. And you have one line per each unit, which is really efficient. In most of the libraries, you have to use either multiple lines or they're having macros to introduce plenty of definitions for one thing. All right, so in a SI system, all of the units introduce the information about the associated quantity kind. For derived units, you specify it similarly. You have named unit, radian, meter per meter. This is definition from SI. Or meter square for steradian, which is also interesting definition. And all other here recipes for all other derived units. For some of them, you may also provide a kind associated to them, saying that hertz can be used only with frequencies and becquerel only with activities. And the same for radian and steradian. For all other, we don't care because there may be different quantities that mean the same but require different units. So if you try to do it in my library, you will get a compiler error saying this is an invalid operand binary expression because we say that hertz and becquerel does not have a common reference. So this is safe. And it's not only about hertz and becquerel because you may think those are totally abstract and separate concerns. No one will ever mix them in one project. But there are different things, like grade and sievert. All of them are really from the same domain. And they can be written like this in most of the libraries on the market. I say most because there's one library, like Aurora Units, really nice library written by ChipHawk, our co-author as well, where actually they decided to not provide one of those. I never remember which one, sievert or gray, because they were afraid that those will end up with some errors from the user side. So they decided in purpose to not provide one of the SI units because they were afraid of those errors, which is already quite scary that you don't have support for SI just to provide safety. Or you can write things like 1 radian plus 1 bit equals 2 steradian. This compiles fine in all of the libraries that I analyzed. Maybe besides Java 1, but paint in Python, all of the C++ library will happily compile this code for you, even though it doesn't have any sense. And this is what we are trying to prevent. So dimension is not enough to describe quantity. Let's talk about affine space abstractions. We have points and displacement vectors, right? This is like time point and chrono duration. We can do an unlimited set of operations on those. And so this provides additional safety and prevents quantity equations that do not have physical sense. Like, for example, I have 2 points of temperature. I should not be able and allowed to add them. It doesn't have sense to add 2 points of temperature. Right?
Absolute that is not doing conversion to Kelvin or anything.
No, it is. This is quantity point expressed as an absolute. The question was if it converts to Kelvin. No, there's no conversion to Kelvin. This is quantity point express a specific point on the scale, and it just uses the units provided here, so degrees Celsius in this position. All right. Actually, we added this absolute like 2 weeks ago or 3 weeks ago as a result of a discussion on stud proposal self-factor, because previously people didn't say that quantity point is enough, especially if you put quantity here. It was confusing to some what actually you deal with. So with this, you are even more verbose, saying that this is an absolute temperature. For quantity, you have to write delta in degrees Celsius to be explicit. You are dealing with delta, so it's clearly readable for everyone what we are dealing with here. And this is mandated for temperatures only. For meters length, you don't have to use those things. You may, but you don't have to. But for temperatures, the multiply syntax will not work. You cannot write anymore like 21 times degrees Celsius because it is misleading what it creates. And also from physical point of view, it's not how this is created. So invalid affine space operations. Adding 2 quantity points, subtracting quantity point from a quantity, multiplying, dividing quantity points with scalars, multiplying, dividing quantity point with a quantity, multiplying, dividing 2 quantity points objects, and a few others. All of this introduce type safety because those operations are invalid and should not be allowed in code. Right? So this is about safety. It provides new abstractions, better abstractions to prevent such operations. And also for temperatures, it separates the concerns for the point and the difference type nicely, so we can implement all of the cases we want. So if you want to fix the Guardian article that I shown you, we provide things like absolute 0, which is an absolute point origin for thermodynamic temperature scale. And we say Kelvin uses this origin. Then we say we have 0 degrees Celsius, which is 273 kelvins relative to the absolute 0. And then degrees Celsius uses this origin as its own scale. And we also have the same for Fahrenheit with different ratio and point origin. Now if I write this one, you have this 43 and 25. This were actually the values used in the article, and you make a delta from those. You will get exactly the title for EU and US markets, this one in degree Fahrenheit. And you have information 18 centigrades, which was the actual difference above average, and 32 Fahrenheit, not 68, in actual temperature unit. And also there's another sentence from the article. By Saturday, parts of Malawi saw a maximum temperature of, and you can write quantity from 0 and convert to Fahrenheit and make quantity from 0, and then you can see the information that maximum was 43, which was 109 Fahrenheit, compared to an average of 25 and 77 Fahrenheit for the time of the year. Right, so here you have delta quantities, the difference temperature, here you have points. And they work differently while converted to specific units. So this allows us to model temperatures properly. Quantity points are more common than most of us imagine. Points are everywhere around us. When we measure something, we typically measure points. We measure temperature points, timestamps, but not only those. Like if you stand on the scale every day to measure new things, this is a readout. This is a quantity point. You should not add those two to each other. But I can subtract them from one day to another to find out how much I lost or gained in the meantime, right? Altitudes of the mountain peaks on the map are expressed as points. Current path length measured by the car's odometer is a point, right? You don't want to add 2 odometer readouts. Doesn't have sense, right? Price of the instruments on the market may also be a point, depending on how you want to model that. Of course, you can always model some of those as quantities as well. It depends on you from domain, from your project, how much safety you want to bring. But those should be easy accessible and used often, more often than they're used right now. Let's come back to Hack and Bricklet bridge case. I promise you that I will provide you the solution for that, right? As I said, the German uses North Sea as a reference for sea level, and the reference point is known as an Amsterdam sea level. Swiss uses Mediterranean sea level for their own ways. The difference is 27 centimeters. As the engineer, actually, I think, or our architect says, the difference of 27 centimeters was certainly known, and everything had been drawn up correctly on the paper. Project manager at Department of Civil Works of the Civil Canton. However, even during the early construction of the face, it became clear that something was wrong. At Christmas 2003, they found out that the difference was more than 27 centimeters. They just forgot which side is lower. And they added the difference to the incorrect side of the bridge, ending up with 24 centimeters of the difference. So they made a typical sign error in calculations. Instead of 27 centimeters, they ended up with 54. If you want to model this as well, you can write Amsterdam sea level, absolute point origin. Mediterranean sea level, it's Amsterdam sea level minus 27 centimeters. And then you can provide some artificial, I don't know exactly the height of this bridge, but let's say it is 330 meters over Amsterdam sea level. And then you can specify the types for altitude measured in Germany and Switzerland, using two different point origins here, but using exactly the same quantity type. And you can safely do all of the calculations here to measure the, let's say, nearest landmarks in the neighborhood, and some deltas of those where the base of the column of the bridges is stated, placed, and then measure all of the quantity points of the actual heights and so on. I will not go into details in this code, but basically with this you have full type safety, and then if you print stuff, you may see exactly all of the values here provided correctly. Bridge road altitude, so at the top of the bridge, the road is for Germany reference is 330 meters. For Switzerland is 330 meters, 27 centimeters. If you will convert this as a quantity from Amsterdam sea level, so basically use the same reference for both of them, you will end up with exactly the same value. This is just expressed in meters, this one is centimeters, but this is exactly the same value when you use the same reference point for both. But if you are using domain specific, they are always also correct. It's just the actual value is different. So all of this brings the safety to us. Now let's maybe see a short summary of things that we cannot ensure with such a library. So some safety pitfalls that still are possible with such libraries. First of all, what would you expect as a result of 5 hours divided by 120 minutes? Think about it, and I will show you the rationale for the actual result in a moment. But if you are having the code like this one, 120 kilometers divided by 2 hours, you expect to see 60 kilometers per hour as a result, right? You don't expect kilometers or hours to be changed to other unit. And you expect just 120 to be divided by 2. So this also means that if you have 5 kilometers divided by 24 hours, you expect to see 0 kilometers per hour as a result. Because you don't expect the library to change the units for you. Library cannot find those values at runtime and change the type depending on the runtime known values. Right? If I knew the values at compile time, maybe I could change the unit to something else in order to prevent the truncation here. But those values are provided at runtime. So if I'm not changing the types at compile time, then this has to result with 0. And to be consistent, when I divide 5 hours by 120 meters, so the example from the previous slide, I end up with 0 as well. I will not change hours to minutes before I do the division. because it has to be consistent. It has to use types separately from the runtime calculations of values separately. This is staying consistent. This also allows us to express ratios that are really big. Like I may have a dimensionless quantity that has really huge ratio or really small ratio, still expressed with integer value of a small value. The problem is that so those are integers, not floating point values, right? This is integer division as a slight note. So with floating points, everything is fine. You will just have some floating point value here. With integers, this is surprising. This is also surprising that actually some of the libraries, namely Aurora units, forbid integer division at all. It's just not provided by the library. It's a valid choice as well. We have to find out what this library should do, what the committee will agree on. But not having division of integer values may be really frustrating for things like embedded industry. They just have to be extra safe to make sure that things like this either not happen or are not surprising to their calculations. By the way, Modulo works okay. Modulo will provide you 1 hour. So it's even maybe more confusing that this plus this will not provide you the initial value, if you know how division and modulo relate typically to each other. But this is considered to be okay because modulo is more like addition rather than division. So it follows the addition rules to find the common unit before you add things. So in this domain, it has to work like this, which may be, again, surprising a bit. We don't have numeric types that are safe, right? Integers can overflow. We already had some really expensive failures, namely Ariane flight V88 crashed during takeoff. Integers can be truncated during assignment to a narrower type. Floating point type may lose precision during an assignment as well, right? Conversion from 164 to double may actually also lose precision. So conversion from int to float actually is also truncating if the integer is big enough and the floating point value is actually quite small. So as I said in the beginning, we are depending on the chrono-like behaviors, assuming that floating points are non-truncating and the integers are truncating, and conversion from floating points to integer is truncating. Other way around, it's not. But it's not true in all cases. We just don't have better ways to say it today. We hope that the type traits that I mentioned already will come soon, and we'll be able to use them in order to be able to say better which are value truncating conversions and which are not. One more thing. Which syntax do you prefer? We have syntax on the left-hand side and syntax on the right-hand side. Initially, my library forced this syntax. So it's unit and a number. Quantity is a number multiplied by a unit. And unit had to be, in case of composite, derived unit has to be put in the parentheses to have the unit part calculated first. But I got at least 3 issues on GitHub saying, why my code written like this doesn't compile? And people say this is easier to read, this is easier to reason about. So this is how we write the things right now. But this means that this is not speed. Maybe surprising. If you put concept on this one, you'll get a compile time error. This is derived unit of hour times kilometer, which is basically length multiplied by time. It's not convertible to speed. Right? You have to put parentheses on that in order to make it work. In order to support syntax on the previous slide, we had to allow this code to compile. Well, this code to compile. Previously, this code to compile. Previously, this was not allowed. And when I had the parentheses, this was basically not allowed, and this worked nicely. Because notice what happens here when you do this arithmetic from the beginning. We are doing here the length quantity, right? Then we divide it by 2. And then we just multiply by h to make this not a speed. Right? So you can have quantities multiplied by unit, which may be surprising to some because of the syntax. This part, 60 kilometers per 2, actually could be a variable with an identifier, like q. So I mean to do q times hour and end up with something different than q was initially as a quantity type. which may be also surprising. This is a side effect of the syntax. I still don't know which one is better, safer. I like the previous one, but I said the users were confused. So yeah, this is another case. I have make length. I take value, multiply by my meter, I get the length. 42 make length works nicely. But what happens if I already have a length passing to make length? I will end up with area, right? I could make all of those not compile, but then user will have to type things like that. However, those problems are a bit artificial because sooner or later they will arise in the compiler messages anyway, because sooner or later you have to assign things to a strong type, not to ctat or auto. Right? So say this is quantity of kilometers per hour or speed of kilometers per hour or quantity of speed, no matter how you spell it, it will be a compile time error right away. Right? Here with make length as well. Or function like this that will just have return type being constrained or the representation type being constrained. All of this generates compile time errors. So sooner or later you get a compile time error while assigning this automatically generated type to something that is predefined in the code base. It just depends how many autos you have before you find a strongly typed quantity. So it may propagate for a while, this error, and then you have to figure out what was wrong. Also, another possible frustration here is that the library cannot prevent some specific operations that may be not the most logical one for humans. For example, length by length is an area, right? Everyone agrees, right? You can also imagine that width by height is an area, like this wall, right? But what does it mean to have height by height being an area? Well, I may say, well, this is height, this is height. Now I have area, right? So in theory, it makes sense. But it's harder to reason about this a bit more, right? The library doesn't care, it just has length, area, okay, fine. So those operations cannot be filtered out. And also, as I said, I showed you this, in some cases, it may be the case. Last but not least, I think, it's the last. Quantity point class templates are structural types because I want to use them in compile time contexts. Like for example here, if you see in Mediterranean sea level, it was using the quantity type passed as a non-template parameter for a template, non-class template parameter, right? So this means that it has to be a structural type. A structural type has really interesting constraints in the language. Structural type is required to provide all of the data being public as of the current language rules, which means that all of my member data that I try to hide from the user, that I try to make sure that they're always correct, are actually public. And this is what I found, because from time to time I'm just going to just search how people are using my library in GitHub or GitLab, and they found that people actually were using my numerical value underscore directly in the code. This was actually the change that they did. They used number, well, but then I removed the number and provided a function with a longer name. So they used number underscore value underscore directly in my member. Please don't use member data directly. This is implementation detail and should not be used directly. It seems I have to obfuscate the name more to discourage people from using it. Don't know if obfuscation would be effective. Maybe a short documentation discourages usage. Such a comment would pop up in most, it should be in most, but it was must IDs, right? Because what this person did, it just written Q or hours dot, and immediately ID popped up the member, right? As a public visible member, and why not to use it? So what I did, I refactored my code after that to this one. So right now it's the longest thing, and no one would choose it from the ID. And I probably will have to change it every single release. But this is unsafe, right? And these are the rules for structural types. We would like to make this private. It's just we can't for now. Summary. MPU is about safety, right? We have automated but safe unit conversions. We prevent truncation whenever we can. Explicit is not explicit enough, and we provide better solutions here. Safe quantity numerical value getters are provided. Quantities of the same dimensions but different kinds are fully supported and really useful. Various quantities of the same kind as well, and the affine space abstractions. And there's plenty of more features that are not maybe explicitly related to safety, but in the library. And you are welcome to try and provide feedback. We want to get as much feedback, as much production experience as possible before it lands up in the standard, because after that, we cannot change anything. This will be fixed forever, and we'll not be able to refactor things, only add if possible. Questions? Oh.